All right, so just going through the chapter 6 review sheet, just a quick video to go through it. So the first one we had was the exponential function, and you're doing a regression. So just type into the list of spreadsheets the x and the y here, okay? And then you're going to go to menu, stats, and then calc, and then choose A with its exponential regression. So we're looking to get it in the form y equals ab to the x, okay? And then your calculator is going to say underneath a equals 1, b equals 3, and then you got to plug it into the formula. So if you want to figure out when x is 7, you're just going to plug in 7 for x and then calculate that out on your calculator. Just type it in, hit enter, and it's 2,187. All right, going on to number 2. From the table, is it linear or quadratic or exponential? We're not going to have a quadratic, so don't worry about that. But linear, exponential, if it goes up by the same amount every time, it's linear. Exponential is going to be multiplying, so the distance between the numbers is going to simply be increasing by the same factor. So here we can see it's minus 4, minus 4, minus 4, so that's linear. The explicit recursive functions, for the explicit, it's an equals a1, the first term, plus n minus 1 times d, which is what are you adding to get from one term to the next. So here a1 is 5. Actually, we changed that. a1 should be 3, not 5. So 3 plus, and then n minus 1 times d, and the d here is negative 4. So just make that change. It's on the answer sheet, so just check that one. We talked about that in class. For recursive, it's an equals a sub n minus 1 plus d. So here's just going to be a sub n equals a sub n minus 1 minus 4. All right, number 3, Thomas bought a new car 10 years ago for 10 grand. It's gone down in value, so that's a depreciation of 8%. Remember, R is going to equal 0.08. Find the value of the car after 5 years. So we're using the formula y equals a to the x. We have to figure out b first, so it's equal to 1 minus r. Remember, the rate is 0.08, and so when we subtract, we get 0.92. So we plug a is 10,000, b is 0.92, and we raise that to the 5th power. Type it in your calculator, and there's your $6,590.82. All right, secondly, doing the functions, we know the base function, the parent function, is f of x equals x. So any changes we make are to this original function. This one has a 2 in front and then a minus 4, okay? So we can tell that the 2 in front is a vertical stretch of 2, and then the minus 4 that happens at the end of that after the x, not in parentheses, is going down by 4. Okay, the second one has a 1/2 in front, so that's a vertical compression of a half, and then we're adding 3, so that's up 3. All right, number 5, we're starting with a to the x, so whatever we do to the a, which is in front of it, then it's going to do that to the graph. All right. Also, if there's a minus in front of that, there would be just like this. So the first thing we notice, it's going to be reflective of the x-axis. The second thing we notice is that there's a plus 3 at the end, so it's just, the 2 in front, vertical stretch of 2, and then the 3 in front at the end is shifting up 3 units. So reflecting over the x-axis, vertical stretch of 2, and then going up 3. So the second one, we have that 2 here, and there should be an a here because that was the basic function. So it's a vertical stretch of 2, okay? It's also now, because the minus is with the x, being reflected over the y-axis, and then the minus 3 at the end means we're shifting down 3. Okay, let us see here. We have a minus 3 attached to the x, so remember that's moving left and right, and it's the opposite sign, and we have this plus 2 at the end. So we're going to be shifting to the right 3 units, and the plus 2 at the end means we go up 2. Okay, here we should have another a right here. All right, so here we have the 1/2, so that's a vertical compression of half. Okay, we have the plus 5 here, so we're shifting to the left 5. Remember, plus, we're going the opposite direction. And then down 7 with the minus 7 there. Okay, on the next page, we have the absolute value of x. So even though it says a to the x here, it should be absolute value of x. So what we see here is we see minus 4 inside and plus 3. So remember, this is left and right. It's the opposite. So it's right 4. And then plus 3 means we go up 3. All right, f. We have the negative in front, so that means we're going to be reflecting. The 2 is a stretch, and then the plus 4 at the end is going up and down. So we have a vertical stretch of 2, reflect over the x-axis, and then it's up 4. All right. This guy, the minus in front, remember, means we're reflecting. Half means we're compressing, left and right, and then up and down. So we have a compression of a half, reflective of the x-axis, left 3, because it's minus, it's in the, actually this should be right 3, my bad. So I'm right 3, not left 3, and then up 2. We got the minus for reflecting, or stretching, left and right, up and down. So reflective of the x-axis, stretch of 4, right 6, and then up 3. So the minus means right, so this should be right, not left, okay? Down to number 7. So recursive formula for the sequence, they give us the first term, which is 8, and they give us a sequence. So we already have the first term, we need the second. So we're going to take A2, we're going to plug it in, okay, for n, and really 2 minus 1 is actually A1. When you plug in A1, you're plugging in 8, and then 8 minus 6 is 2, so A2 is 2. So A3 would mean that we're doing 3 minus 1, which is A2 minus 6, so that's 2 minus 6, or negative 4. And so our first 3 terms are 8, 2, and negative 4. All right, we want to find an equation. So this, remember, is a going up by negative 6. So this is an arithmetic. So the formula is an equals a1 plus n minus 1 times d. All right, we're going to plug in the first term, which is 8, n minus 1, and then d is negative 6. And then we just substitute 20 in. And we're going to get an answer of negative 106. It's the same thing for the next question. This one's times, so this is going to be a geometric. So when I find the first 3 terms, a2 is a sub 2 minus 1 times negative 2. And then for a1, we put in 4, and that gives us negative 8. For a3, we're doing a sub 3 minus 1, which is really a2 times negative 2. That's negative 8 times negative 2, or positive 16. And so we get these numbers. So the equation here is an equals a1 times r to the n minus 1. We plug in a1, which is 4, and then n is 10. Okay, and r is negative 2. All right, and then all I have to do here is evaluate. That becomes the 9th power, and that gives me negative 2,000. All right, number 9. So this graph should look like an absolute value starting at the point 0, 0. And all I'm doing is shifting it over 3 to the right and up 1. So I'm going to take my graph, which is the absolute value of x, okay? Right 3 means we put it inside the absolute value, and we got to do the opposite sign. So it should be plus, it should be minus, not plus, minus, okay? And then plus 1 at the end. All right, second one. Here's our graph. So once again, we're moving left 4 and up 2, okay? And also we can see that this is actually going up higher. It's supposed to be going 1, 1, 2, 2, 3, 3. It's supposed to be going on this line, but instead it's going up 2 and over 1. So that tells me that there's a vertical stretch of 2 here. And then I'm moving to left 4, so that's x plus 4, and then up 2, so then x plus 2. Okay, here we can see the graph is just 1 over 1. It's going 1, 1, 1, 1 all the way down. So it's got a slope of 1. So we got y equals, there's a slope of 1, down 1 over 1. So it's just nothing in front, or a 1. And then we're going right 4, so x minus 4, and then up 6, so plus. Number 10 on the set of axes below. Apparently that's going to stay here. All right, I got this graph. We said in class that this, we're going to get rid of that and change the negative 2 and move it in front here, okay? So to graph it, what we're going to do is we're going to take the center point. The center point is supposed to be, let me just do this real quick. It's supposed to be at the point 0, 0, okay? So it's supposed to be here. This tells me to go, this is supposed to go right 1 and then up 2, so the point should be here, okay? And then I'm going to go negative 2, so it's flipping over the x-axis, and then I'm going to go down in both directions. So my slope of 2 means I go down 2 and over 1, down 2 and over 1, and I'm going to form that graph. Except this graph should actually be, get back there, okay? Should actually be over there, and it should look like that, okay? That's what the graph should look like. All right. Okay. We're going to graph the following piecewise functions. So what we need to do is first we need to check the endpoints. We need to see where this 2 is actually going to be on the graph. I know it's an open circle because it's not a greater, less than or equal to or greater than or equal to. So I'm going to take 2 and I'm going to plug it into that function. So 2 to the 2, which is 4, minus 3 is equal to 1. So I know that there's a point at point 2, 1. I'm going to go over 2, 1, over 2, up 1. Y. And I'm going to graph my first point there. And it's going to be an open circle. Okay. And then I'm going to fill in the graph. All right. So we're going live here. All right. So we're going to 2, 1, over 2, up 1. I'm going to put an open circle there. And then if I do the point 1, 1, right, if I plug 1 in, that's going to be at negative 1. So if I put 0 in, I'm at negative 3. Okay. That's right there. Actually, negative 2. Okay. Let's go rather big here. If I put negative 1 in, that's going to be half. That's going to be at 0.5. That's way too big. All right. And then I'm going to drop a little bit closer, and I'm going to get closer and closer to, but not getting there. All right. And so my graph is going to look like this. Yeah, let's get rid of that for a second. It's going to look like this. There's my open circle. Graph's going to come down in this direction. All right. It's not supposed to actually touch. So it's going to look something like that. All right. And I'm just going to draw it again so we get through there and heads off that way. Okay. The second one, I'm going to plug 2. So when x is equal to 2, because that's the value right there, I'm going to plug that in here. So negative 2 times 2 plus 4. And this is really negative 4 plus 4. So this is equal to 0. So I know my point is at the point 2, 0. Okay. So we're going to go to the point. I still did this wrong. Oh my gosh. Okay, let's go back out of here. Give me this. Freeze. 2, 1. 2, 1. There's my open circle right there. Okay. We know we put 1 in here. We put 0 in, we're going to get 0, negative 2. If we put 1 in, it's going to be negative 1. So it's right there. Okay. And this should be a closed circle. 0 is at negative 2. Then I got negative 2.5. And then we're heading closer and closer to that negative 3 line here. Okay. So my graph is going to look like this. That's a little bit more accurate. Okay. The next point is at the point 2, 0. So that's right below. I just want to draw this a little bit better so that it's not going to cut into the other line. That's good. Okay. So I have a point here at 2, 0. It's a closed circle this time because it's an equal sign. And then it's a slope of 2, negative 2. So I go down 2, right 1. And here's the next point. And there's the next point. And there's the next point. So my line looks like this. All right. Let's do this the right way. And I'm going to get a line that looks like this. And so this is what my graph looks like. So open circle here. Okay, that's open. This one's closed. And then the graphs are going in both directions. So make sure you check those endpoints. Okay, to find f of 2, when I plug in 2, because 2 is less than or equal to, I'm actually going to plug into this function right there. So f of 2 is equal to negative 2 times 2 and then plus 4. So this is negative 4 plus 4, and that's 0. That's what f of 2 is. All right. Just to make this easier and so that you can read, I'm just going to undo this real quick. bear with me, and put up the old graph, which we know we're going to ignore and use the one we just used. But I had all the work done, so it's just going to be easier this way. Okay, so when we plug in 2, I get negative 4 plus 4, which is 0, so f of 2 is 0. If I want to find the value of f of 0, remember that f of 0, right, when x is less than 2, so 0 is less than 2, we're actually going to plug into this function, okay? So I'm going to take f of 0, which is put a 0 in for x. So 2 to the 0 is 1. 1 minus 3 is negative 2. So f of 0 is negative 2. I could also come on 0 when x is 0. That's right here. And then I can see, let me plug it in. Oh, it's right here. That's right, wrong graph. We can just check the graph. Number 12. Car was purchased for $25,000. Research shows average depreciation rate of 18.5%. So that's 0.185. Move the decimal spot 2 points to the left or divide by 100. We want to create a function that uses v of t and t. We have to use those two things. So to the nearest tenth, how much will depreciate from years 3 to 4? So we're using that function, v of t is equal to, and that's ab to the x. So I need to figure out, and I'm using v of t and t, okay, instead of x. I need to figure out what goes in the parentheses. So it's depreciation, so it's 1 minus r. R is 0.185, and that gives me 0.815. So I plug that in, take my calculator. I'm going to plug in 3 first and evaluate and get $13,533.58. And then plug in 4 and evaluate and get $11,029.87. And then I'm just going to subtract. And I get an answer of $2,503.71. All right, Nora is inheriting a savings account started by her grandfather when she was born. So we have the function 5,000 is equal to 1.013 to the 25, which gives the value of the savings account on her birthday. That would be today, right? If today was her birthday, she was born, she started it at the time 0. Today is her birthday, so how many years later is it? We want to know the following. What was the initial amount? So remember, the initial amount is supposed to be, right, y, that is not what's supposed to happen. Y equals AB to the x. So this is my initial amount, okay? This is my growth factor. Remember, it's equals to 1 plus r, okay? And then this is the amount of time, that's the exponent. So the number in front that we start with is 5,000, so that's the initial. The rate, right, is 1 plus r, so that's 1.3%, right? That's what's after the decimal. Over 2 spots, 1, 2, 1.3, or as a decimal, it's 0.013. So just figure out if they're asking you for a percent or not. Usually it will ask you for the rate as a percentage. How old is Nora? That's the time, which is 25 years. And the value we just evaluate is $6,905.68. 14, on the floor of the Kodak Hall in the Eastman Theater, the number of seats per row increases at a constant rate. So in the third row, so imagine that you just have, now constant rate means that it's arithmetic. So just imagine that you could put down 7 blanks, okay? We have 31, or 6 blanks really. The third row is 31, the sixth row is 37, and we want to know how many does it take to get from there to there. So really, we want to know what's the difference between 31 and 33, and then it's 1, right? 1, 2, 3 jumps. So we just divide by 3. And that gives me an answer of 6 divided by 3, which is 2. So it takes 2, I'm adding, plus 2, right, to get from there to there, and then plus 2 to get from there to there, and then I'm subtracting 2 to go backwards, okay? So when I do this, I know it's going to be 35, 33, 31, 29, 27. So how many seats are in row 20? We're going to make that equation. We know the formula. It's AN equals A1 plus N minus 1 times D. A1 is that first term here, that 27, right? We have 20 for N, and then D is 2. So really want to know for the 19th. And then when we evaluate here, we get an answer of 65. All right. All right, question number 15. The pattern continues right next explicit in recursive formula that represents the number of squares in the sequence. So design 1, how many squares does it have? It's 3, and 5, 7, 9, and so forth. So it's basically plus 2 every time. So it's arithmetic, okay? So the explicit formula is an equals a1 plus n minus 1 times d. So I plug in, a1 is 3, n is, we don't know yet, and d is that plus 2. So we get that formula. For recursive, it's an is equal to a sub n minus 1 plus d. I just plug the d in, and it's 2. And we're done. All right, that's it, guys. Hopefully that helped. See me tomorrow if you have any questions.